All right, guys, we're still continuing with solving exponential equations, but this time we're going to solve exponential equations that have different bases. So their bases are not going to be the same. So we're going to have to use what we know about the properties of logarithms in order to solve these. Also, you'll notice that it says solve each equation and round to the nearest hundredth. And this is going to be the point where we're going to need the Desmos graphing calculator to be able to do some of these calculations, okay? So let's look at example D first. And you'll notice I have more examples here because I do think these are a little bit harder to understand, okay? All right, so we've got 4 to the x equals 17. Now I've got to create this into a logarithm. So let me remind you that what a logarithm means is this. X equals b to the y, if and only if, that's what that IFF means, if and only if y equals log base b of x. So I'm going to write that up there so you have it to refer back to. Remember, your base is always the same. Base is the same for the exponent, and base is what it is for the log too. Okay, so I have 4 to the x equals 17. So 4 is my base. So that means the log of base 4 of 17 has to equal x. Wow. It's already got the x isolated for me. So now all I need is a calculator to determine log base 4 of 17. So let's go to Desmos, and I'm going to show you where to get this. So down at the bottom of your screen, you'll notice that there's a keypad. You'll want to pull that keypad up. Then you're going to want to click on Functions, and then we're going to do this log base A because we need to do a log base 4. So log base A, and then you're going to put in 4, arrow over to where you're inside the parentheses, and put the number 17 and hit enter. We're rounding to the nearest hundredth, so that's going to be 2.04. So our answer here is x equals 2.04. Okay, let's try another one. 8 to the x plus 1 equals 3. Okay, we're going to have to set up our log. So log base 8, our base stays the same, log base 8 of 3 has to equal x plus 1. Now this time, my x is not isolated, but the only thing that I need to do is subtract 1 from both sides in order to solve for x. Now here's where I want you to be careful. You cannot say 3 minus 1 and make that 2. Do not do that. That is wrong. You have to say log base 8 of 3, figure that out, and subtract 1 from it to get your x. So if you write log base 8 of 2, that is wrong. You cannot do it that way. So be really careful about that. That is the most common error that students will make when they're doing these problems. Okay, so I'm going to go to Desmos and type in log base 8 of 3 minus 1. Okay, so we're going to use that function, log base A button, and we're doing the log base 8. Now notice of 3, and then I come outside of that to put the minus 1. Okay, I don't put the minus 1 inside the parentheses. All right, so if I round to the nearest hundredth, this is negative 0.47. So x equals negative 0.47. That's our answer. All right, let's look at example F. 5 equals 2 to the 3x plus 2. Okay, so we're going to do log base 2, because that's what our base is. Base is 2, base is 2. Log base 2 of 5 equals 3x plus 2. Okay, now this time I've got to subtract 2. And remember, it's not 5 minus 2. It's log base 2 of 5 and then minus 2 on the end. Okay, now that equals 3x. Okay, I can't have that 3 over there with the x, so now I've got to divide by 3. To undo multiplication, you divide. All right, so this is what I'm keying into Desmos. Log base 2 of 5 with a minus 2 and all of that divided by 3. So let's go over here to Desmos. I'm going to go ahead and close those out. Okay, so we're going to have, I'm going to put parentheses around this to start with. I don't know if I need to or not, but I'm going to do that just in case. A log base 2 of 5, and then it's minus 2. Okay, then I'm going to go to outside here and do divided by. So you may have to do that. Put the parentheses in, that is, divided by 3. All right, we get 0.107. So if I round to the nearest hundred, that's going to be 0.11. So my answer here is x equals 0.11. Okay, let's look at example G. 2 times 10 to the x minus 1 equals 15. Now, up here, we didn't have two things on a side. So the first thing we have to do here is get rid of that 2 that's with our exponent. So we're going to divide both sides by 2. So that's 10 to the x minus 1 equals 15 divided by 2, that's 7.5. So I'm just going to go ahead and convert that to a decimal. Okay, now we convert it to a log. Log base 10, so that's the common log. Log base 10 of 7.5 has to equal x minus 1. Okay, this time to solve, we're going to add 1. Now again, when you add 1, you do not make this 8.5. Don't do that. So this is log base 10 of 7.5, and then we've got plus 1 on the end that equals the x. Oh, let's go type this in Desmos. So we've got to go to our function, and we can use the common log here because it's 10, okay? If you forget that, it's okay. Actually, I'll just go ahead and use the one we always use. Log, you can put base 10 there. It's fine. It works the same way. So log base 10 of 7.5, and then a plus 1 on the end. And that gives us 1.875, so that's going to be 1.88 if we round to the nearest hundredth. So x equals 1.88 for that one. All right, let's try H. 4 times 5 to the 3x plus 2 plus 6 equals 17. Now, before we can solve this one, we got to isolate this 5 to the 3x plus 2. So first, I'm going to subtract 6. All right, that's 4 times 5 to the 3x plus 2 equals 11. 17 minus 6 is 11. Then we have to get rid of that 4. So we got to divide both sides by 4. All right, that gives us 5 to the 3x plus 2 equals, if you do 11 divided by 4, you get 2.75. So I'm just going to go ahead and write that in, 2.75. All right, now we can do our log. So log base 5 of 2.75 equals 3x plus 2. All right, now we got to subtract 2. Do not subtract 2.75 minus 2. You can't do that. So this is log base 5 of 2.75 minus 2 equals 3x. And I know I'm running into this other problem over here, so I'm going to do that. All right. Now we've got to divide by 3 on both sides so that goes away. All right, now I'm keying in log base 5 of 2.75 minus 2 divided by 3. That's what I'm keying in the calculator. So let's go put that in. And again, I'm going to put that top in parentheses. So functions, log base A, and our base this time is 5. Log base 5 of 2.75. Now you've got minus 2 on the end there. And then come outside that other parentheses and hit divided by 3. All right, we get negative 0.457, so that would be 0.46. Negative 0.46 would be our answer. All right, pause the video. Try example I here, 10 to the x minus 1 equals 55. That goes back down to something more basic like what we did up here at the beginning, and see what you can do with it, and then come back and I'll work it. Okay, let's see how you did on this one. I'm sure you did great. So we're going to set up the log here. Log base 10. Remember, your base is still your base in both places. Log base 10 of the 55 equals x minus 1. Okay, so to solve for x, we're going to add 1. Do not add 55 plus 1. It's log base 10 of 55 plus a 1 that equals x. Okay, so let's go to Desmos and see what we get. So log base 10 of 55, and then we're adding 1 to it. All right, we get 2.740, so that's going to be 2.74. So x equals 2.74. All right, if you have trouble with these, like I said, I think these are the most difficult ones. So please reach out and let me know you need some help with it, okay?